All right, so let's switch gears here and talk a little bit about instrumentation. And so this goes in as a part of this planning process, but we want to make sure that we're always selecting instruments that are going to decrease bias and give us the most accurate results possible. So, for example, the scales that we use to collect data, whether it's on a plant science project like for tonnage or yield or whatnot, or on an animal science project for feed or animal weight or whatever, is actually a really big consideration. You may not think that it is, but using an old balance scale actually opens you up to bias, because the way that these balance scales work is that the person operating the scale, makes a judgment call on when that lever is in the center, and that becomes the official weight. And so if you don't have the same person making that call every single time, then you could be opening up your data to actual bias. And so one way to combat that is to actually use like a digital scale that is kind of foolproof, right? You put some feed on there, it's going to calculate out to 2 decimal places, and it's going to give you a really accurate reading. And so that's one way to really control bias, is just by using the right equipment. When it comes to bias, we want to make sure that we are reducing subjectivity. Okay, so we are reducing the amount of thinking that the person collecting the data has to do, and the amount of decision making that has to happen. And so this is where some of the blind studies come in. And so you may have heard the term, in a single blind or a double blind study. They use these a lot in pharmaceutical research and in psychology. But a blind study is where the researcher taking the measurement or collecting the response variable is unaware of what the treatment assignment is on that experimental unit. A double-blind study, which we use a lot with human subjects, is where the researcher, the person collecting the data, and the subject, the experimental unit, are unaware of what the treatment is. And so this is where we use things like placebo drugs or something like that, where every individual person is getting a drug, but one of them might be just a placebo, like flower drug or something like that, whereas the other one actually has the biochemical compound in it. And so these blind studies are really, really nice because they really reduce bias a lot. Step 7 here is all about implementing the experiment. So now that we've got it all planned out on paper, the next step is to actually do it. And so this is where you're going to spend time measuring the treatment levels, considering the application of treatment, so how treatments are going to be applied. Some things to think about on the plant science side here is if you're applying like a fertilizer or, an herbicide or something like that, you first need to know what your experimental unit is, because that's really probably going to dictate the equipment that you use. So if your experimental unit is a pot, then you probably need to use a hand sprayer, right? However, if your experimental unit is an entire field, then you probably need to use a sprayer on a tractor. And so those type of decisions become really important. And you may even want to do some pre-trial testing of the treatment materials just to make sure that you are using the best equipment possible and you're applying or collecting the data in the best way. So research personnel is a big component here too. You always want to be thinking about who the people are that are going to help you collect the data. You want them to be reliable people, especially if you are collecting data early in the morning. So I'll tell you a quick story. On several research projects in grad school, we would do them as a team. So there was like 30 grad students in animal science, and we would all help each other. And it was understood that if you helped somebody on a research project, they would turn around and help you. And there was 1 to 2 people that ended up being the same people every single time that said they would help would go out, party hard the night before, and then not make it on time to collect data at, 4 or 5 o'clock in the morning. And so they became really unreliable. And then other people had to step in and collect their data. And so then the integrity of that data is questioned because somebody is collecting two pieces of data when they really only had time to collect one. And so the people that you get to collect data on a research project is a really, really important decision. And then you're going to want to make sure that you train them very, very well. All right, all of these things are going to help you minimize errors. Okay, so prior planning prevents poor performance. It's the 5 P's of research. Prior planning prevents poor performance. And the other thing to remember here is that to use the KISS method. So keep it simple, stupid is the golden rule when it comes to research. Just keep it simple. Whoa, I went backwards. All right, so collecting data really comes down to a few things that we've already mentioned, but making sure you're using the proper tools, not collecting, or that you're collecting too much data rather than not enough. So always collect more data than you think you need. Having some sort of permanent record is really, really direly important. So this could be a notebook, a lab book, it could be on paper, it could be on a laptop. You want to make sure to minimize having loose papers around. You want to make sure you're not collecting data on the back of a can of chew. You want to make sure that you are not recording data on the side of a barn. All of these things have happened before. That's why they're examples here. Okay, so what ends up happening is the more times that you write a number down, the higher the chance of you transposing a number. And so there becomes a lot of problems with copying a data. So you want to make sure that you're always checking against the original data if you are moving data from like a piece of paper onto a computer. When it comes to collecting data, like on data collection days, you want to make sure that you divvy up tasks. So if you are the project manager, you are in charge of that whole situation. And so people need to make sure that they are listening to you. And so you can assign people to do whatever task you would like. Just make sure that they are properly trained and that they are the measurement taker for that particular point for the entire data collection period. And sometimes it's really helpful to have a recorder. And so a recorder is really important if you are doing something that is like a repeated measurement. And so this is where you can have like a treatment assignment or something. And so those recorders become really, really important because you can go back and actually re-listen to data in an audio format. Some other things to consider as you are setting up a project is how you're going to analyze your data. So we've already said this, but I'll say it again. You want to make sure that you plan your analysis ahead of time. An easy place to start is with simple statistics, so descriptive statistics like we've already been through. So things like means, medians, modes, variance, standard error, standard deviation, and confidence intervals. Those are easy places to start when analyzing data. You then can take that information and step up your game to the actual data test or data analysis process, which we're going to get into in the next few weeks. You also want to make sure that as you analyze your data, you're using the correct analysis to be able to interpret your results within the parameters of the study. So this is a really key bullets here. You want to make sure that you are interpreting results within the parameters of the study and not trying to interpret results into a bigger population or a different population that it wasn't actually tested on. So you need to make sure that you're also aware of the possibility that the conclusions that your data analysis process resulted in are just wrong. And sometimes you can go back and you can adjust appropriately. And that's why it's important to know and to be able to manage the statistical analysis process. All right. So the last point here in this whole planning process is to report the data. So keep in mind, these are things that you're going to be thinking of way ahead of time. So you need to make sure that you're identifying the audience that you are conducting the research for. So is this going to the scientific community, like in a peer-reviewed paper? Is it going to be published in an extension report, or is it going to popular press? Keep in mind, I cannot stress this enough, there is no such thing as a negative result. There have been several times in this class and in other projects as well that we get to the end of a project and there is no statistical difference between a treatment. And you know what? That's okay, because that's still giving you really good information. Okay, so no difference between treatments is still information. Okay. You also want to make sure that you consider how you're going to relate your work back to the original question. Okay, and I am always a big proponent that any work that you do, especially in agriculture, needs to relate back to economics somehow. So we do a lot of this research to try to make producers more cost effective, to do things better, to save water, to preserve soil, to anything. And so all of that is associated with cost. So economics needs to absolutely be a big part of this planning process.